Hi, everyone. So my name is Christopher Bruton. I'm a network architect at CENIC. I'll be talking about the CENIC-AIR and several science DMZ options that CENIC's offering to our members. I'll acknowledge my co-authors, Robert Kwan, he's our VP of Engineering. He's not here today. And then, of course, Tom DeFonte, who you all know, who has many hats. So I think most of you have probably heard of CENIC. We operate CENIC's research. We operate California's Research and Education Network, which is called CalREN. This map shows our hub sites across the state. We serve UC system, Cal State system, independent institutions like Caltech, Stanford, USC, as well as school districts, libraries, community colleges, and probably many more I haven't mentioned. So, of course, our network plays an important role in the network infrastructure used by the National Research Platform. So I think most of us have an idea of the science DMZ concept, but I wanted to define how we understand it at CENIC. So NRP nodes and other high-performance computing applications require high-performance networking access. And the problem is this generally can't be satisfied effectively by campus enterprise networks, which they're designed to provide internet access to as many campus users as possible, but are not optimized for high throughput or low latency. So what we're seeing here is every device between the edge and the end user has the opportunity to introduce latency, congestion, firewall restrictions, and can make troubleshooting much more challenging just because of the number of devices that are involved. So the solution, which is called the science DMZ model, I think that term originally was proposed by ESNet. We address this problem by bypassing as much of the campus infrastructure as possible. So this diagram is obviously conceptual, but the goal is to place the computing infrastructure as close as possible to the network edge and to the CENIC backbone in our case. So I'm going to discuss two science DMZ models that we already see at CENIC member campuses, and as well as two more models that we're in development and newly offering as part of CENIC-AIR. So option one, we're calling this the virtual science DMZ. So this doesn't require any new physical infrastructure between the campus and the CENIC edge. This may be the fastest way to build a new science DMZ since it doesn't require new circuits, new hardware, anything like that. We make use of the existing physical connection. We'll provision a special VLAN for the science DMZ, which would typically be a direct layer 2 connection to CENIC's HPR network, which is our high performance segment of CalREN. The campus itself is still going to be responsible for routing and switching, as well as the physical infrastructure on the campus side. So the switching infrastructure at the NRP nodes. So option two is, we actually have two option twos, 2A and 2B. But they're both called a physical science DMZ because this involves a new physical connection to CENIC that's dedicated to the science DMZ. So option 2A, we still there's still an existing campus border router, but CENIC can provision a second connection to the CPE. If there's a CPE, some of the larger campuses actually have a direct circuit to the CENIC hub site. But either way, it's the same concept. It's a physical connection dedicated to the science DMZ. The campus still manages their own border router, and they plumb that connection the way that works for them. So option 2B, and this is maybe a more useful option, but it does come at probably more of a cost to the campus. This, instead of a physical connection to the same campus border router that the enterprise uses, the physical connection is to a dedicated science DMZ switch. So the campus, they'll still own and operate this science DMZ border device, but may be advantages in separating completely from the main border router. They could use a dedicated device with better performance, deeper buffers, whatever makes sense. And this can also satisfy campus IT groups who may not want experimental network usage on their production border device and may not want to deal with support and any unique provisioning requests. So a bit of an interlude. I know Jerry mentioned CENIC-AIR and the Tide project a little bit. I didn't like the approved language that my communications department gave me to describe this. So I'm just giving some quotes from Larry and Tom. But essentially what CENIC-AI resource is it's a new branding of the California portion of the National Research Platform. That's the surface level. It's just a new name for something that already exists. But this represents CENIC's commitment as an active participant in the NRP program, NRP project, beyond just being a hands-off network provider. So we're committed to providing design and engineering support to campuses to establish their science DMZs and to facilitate access to the National Research Platform. So with that in mind, I'm going to present two more science DMZ models that reflect this active approach. So here's option 3. So this is geared towards campuses that can't host their own physical NRP nodes. So for example, they may lack space and power, or maybe they don't have enough funding or staff to maintain the nodes. But the campus may still want to support education and research projects that need access to a science DMZ. So what we essentially would do is extend a science DMZ from one campus over the CENIC backbone on a layer 2 level to another campus. Then that campus could maybe have a dedicated computing lab, that is separate from their enterprise network and has this direct layer 2 path into the science DMZ. So this is still an option in development, and I think there's a lot of room to design this to a particular campus's use case and needs. But essentially, it's a virtual extension of a science DMZ across the wide area network. And then option 4, we're calling this the managed science DMZ. This is perhaps the most radical new model that CENIC is offering, because traditionally we've been fairly hands-off beyond the CENIC network edge at campuses. So in this model, CENIC will provide and actively manage a science DMZ device on the campus. And this includes 24/7 production level support from the CENIC NOC. This is an integral part of the CENIC production network. So the campus would simply need to connect their NRP nodes to the switch, configure IP addresses, default routing. CENIC can provide some IP space, or the campus can use their own. We'll take care of the routing and provide simplified access to the Caloran HPR network, as well as to the internet on a single routing instance. I'll mention that currently we're only offering this for CENIC-AIR NRP uses. In the future, we may offer this as a more general offering, but again, managing a device on a campus beyond just a CPE is new to us. So this is still considered kind of a pilot project, but we're excited to offer this, and we hope that this will help more campuses become part of the National Research Platform and establish their science DMZs on their campuses. So thank you. Thank you for listening. If you have questions, you can contact any of us. If you're interested in pursuing any of these options for your campus, you can also contact your existing CENIC contact, your project manager, and we'll get started on this. So thank you.
Questions for Jerry or Chris?
I have a question for Chris.
Yeah.
I'm going to display my complete ignorance. Can we go back to the option 4?
Yes.
So I know that you have equipment on our campus, but do you have CPE means that you have equipment on every campus in the CSU system?
Not necessarily. So I don't know offhand which campuses have an actual CPE or not. I think some have a direct provider circuit to the CENIC backbone, and they actually use their own. So essentially, in this diagram, we would bypass the CPE, and that gray link would be directly to a Calran hub site. So
in some cases, in order to implement this, in some cases, you'd have equipment at a location for the first time.
Yes, and I think that's not reflected necessarily in this diagram, and we'd have to work on exactly the design for that, because that could require a new circuit. If we wanted to do this exact approach, we'd have to bring up a new optical circuit, dark fiber or lit fiber from the campus to the CENIC hub site. Or it might make sense to add a CPE if there wasn't a CPE before. I think what we wouldn't do is put a managed Science DMZ switch downstream of a campus border router that the campus manages. We don't want to get into that business. We still want to manage every part of this path between the device and the CENIC backbone.
And if I can ask another question. So the obvious next question, of course, to this diagram is, what if the campus is an instrument, a data producing instrument? Would you be willing to have that also plug into that Science DMZ switch?
Can you clarify?
So let's say,
Okay.
pick the campus has a cryo-EM instrument, or a gene sequencing instrument, or an electron microscope, or pick your poison, right? And all of these instruments are incredibly useful if you can put the data somewhere.
Yeah.
And so they're sort of obvious. They're almost an obvious. You're almost asking for it once you bring the switch in.
Right.
That you enable the campus to invest in such instruments, where previously it's almost impossible for the campus to even consider such an investment, because it's pointless, because its plug doesn't go anywhere.
Yeah. So I think my officially, I can't say yes, we can do that, because officially this option is only for CENIC-AIR use cases. If you can construe that instrument into a CENIC-AIR use case, then yes, I'd say
we will.
Yeah.
This is actually one of the things I want to do more, and what we wrote into the original PNRP proposal is that we wrote into the proposal that we want to do more instrument integration. We haven't done, that's not been the first priority, so it hasn't happened to the extent that I would like it to happen in the future, but it's on the to-do list. We even had in the proposal different types of instruments listed, and had people listed, names listed, whose instrument we would be integrating, and it's sort of on. It will eventually happen, and we'll be talking more about this once it happens. So that's why I asked the question.
Yeah. And there are cryo-EMs, for instance, at multiple CENIC-connected campuses.
Mm.
And so having a distributed storage for cryo-EMs across CENIC is something that would make a lot of sense. It's a lot of coordination with the campuses, with the owners of those things. But I mean, if you start dissolving these barriers that are needless,
And let me go away from the life science. I mean, I have life science in my head because I'm at UCSD, because UCSD is basically a health management organization with a little bit of research attached. And one of the things that is an obvious one, and that we also wrote into in connection with the Midwest, is aquaculture. And we've had conversations with Fresno recently on aquaculture applications on NRP. So there's a real growth area, especially in rural areas, in the realm of aquaculture. That we want to push on in the future, and that also would fit right in there.
Yeah. Okay, thank you. Yes, I will. I'll take this feedback back and make sure it's known within CENIC that there's interest in this. So,
yeah, just one quick comment on pushing those big instrument data streams or data tranches up. That's a very common failure mode for us. Even though at UC Santa Cruz we have a very capable science DMZ and a robust Globus file transfer infrastructure, that instrument generates data faster than we can push it out. And so to have it go directly to some federated source where collaborators could be added simply by joining them to your namespace is highly desirable for us. Now, I have a little work to do to convince our researchers to move their workflow into something that makes more sense like that. But from my side, from the IT side, clearly we can't continue as we are. The instrument generates more data than we can push in a 24-hour cycle.
All right, thank you both.
yeah. Great.